All right, so the Aerospike server. It's pretty much,
record?
yes, I hit record. So this is pretty much the exact same thing. Oops, go build. Except it's the exact same website, except built using Aerospike API instead of managing it all ourselves. So let's move this over to serve/serve. Copy our templates. Copy -r, our templates folder, over to serve/templates. All right, and let's just reboot the system so that system D can start up the new server, because that seems to be easier overall. Let's see, is it done yet? No, done yet? Yes, cool. Reboots fast. No bulky graphical system to have to initialize. So if we go over here, oops, the IP address. If we go over here, it is not working. Why is it not working? Isn't that what you always want to know? System, service, serve, status. Okay. Failed to start. Scheduling restart stop go server. I think I've seen this error before, but I don't actually remember what it meant. Invalid argument. We've got our log file here. So it got in. It's just this log file here, which didn't actually get anything printed out. Okay. That is very odd.
You want to look at the code? Maybe it's like, would it be the Go code? The build?
I think it's the serve.service code.
Serve.service code? Because the serve.service will launch the Go code, right? So if the Go code had an error, maybe that causes an error with serve.service.
Nope, it's failing again. So yeah, it's our serve. It loaded that. Start limit.
And hey, just FYI too, this is like also, I think, a very valuable learning moment. So if you're watching this online or in the class right now, just like seeing how does somebody troubleshoot something.
Yeah, main issue I'm hitting here is that we don't have our log file.txt. So let's try just running it manually. Okay, failed to connect to host, localhost. Is Aerospike down? So yeah, I just tried running it manually, and it's telling me it's failing to connect to our localhost port 3000, which is where Aerospike is. So let's go back over to our management console, which is completely down. Nice. All right, so let's try sudo service Aerospike status. Aerospike never got turned back on. Start. I don't know why it didn't get turned back on, but all right.
There you go.
Sudo service serve start status running. Okay. All right, it works now. So, yay. So it's all up now. I'm actually using a query. Let's see, did the management console get on? No, it didn't. I don't know why these aren't turning on again, but
Where did we set it for those to turn on?
when doing a system start on it should put it on boot. But in any case, all right, here we are in our management console. So previously I was using two maps, one for user name to user and one from ID to user. Aerospike is a database. I can't do that quite that way. So I've got my IDs as the key, similar to data store, but I need to be able to query on it in order to get the username. App Engine generates a index.yaml file automatically when you're running locally, and that's how it generates its indexes for things you need to query on. Aerospike will not manually. So we need to go over here to definitions, select our bar namespace, which is where we're running off of, and add a new index. We can give it whatever name we want. So this is the username lookup. We give it the bin, which is the actual item that it's going to index on. So that's username with a capital U because that's what it's named in our Go code. And we say it's a string, and we give it the set name. I think I've got it set to users. So that will spend a while to, okay, username index added. So now it's indexed over username, and so the website will fully work now, I believe. So if I try to create a new account, log in, it worked. Okay, everything worked. If I hadn't, that login would have failed because it would have tried to look it up by username, and it would have failed because there's no index for username queries. So FYI, there's a way to, the Aerospike API for Go has got a function that will do that too, but it only needs to be run once total, so it's not quite worth putting into our server. Just let our management console do it the once, and then we don't have to worry about it ever again. So website's exactly the same. Let's close these. Go to the Aerospike one. All right, so I'm importing Aerospike. This is a really long package name, so I'm just going to call it AS instead, Aerospike. Got our user struct, got our templates. Instead of having our two maps, we've got a pointer to an Aerospike client. So we will create our template file as before, we'll set up our log file as before, then we call this Aerospike, new client, give the IP address of any node in our database cluster, and it's on port 3000, which is what Aerospike runs on by default. So if you were running on multiple machines, you'd make sure that this IP address is your private IP address. I'll give you your client, panic on error, defer client close. The client is fully Go routine safe, and it will actually utilize multiple connections as a connection pool. So I think it creates like 100 connections or something. So if you're getting a lot of traffic, it can just keep reusing those connections without having to recreate a connection every time, which can be slow, depending. Since we don't need to handle saving on Control-C, I don't have to bother with that. The routes are exactly the same. All right, so login page is exactly the same. Logout and create page are both exactly the same. So the 3 pages where we're actually accessing the database are what changes. The index, the login, and the create. All of them have actually gotten bigger from our own management code, but it's much, much more extendable with a database. So I'll start off with create because we need to create our stuff. So get the name and password, check if it's, do our normal checks, UUID, hash pass, create the actual U. All that's exactly the same. So now we create a key. Same as an App Engine, you create your keys. So except I don't think Aerospike's got new and complete key. I think you just have to manually do it all yourself. So make sure you know your UUID generation. So you give it the namespace, which is, so namespaces are like basically like separate databases. You got your cluster, your namespace is your database. So if you got multiple websites running off the same cluster, you can have them all separate from each other with different namespaces. So you should have one namespace per server, per separate website. The second argument is the set. Set is like the kind from data store or tables from SQL databases. So we got to give our users kind or our set. And then we give it our actual key. So I'm just giving it, so my key is my UUID. Your key can be any type. This is actually, if you look in Aerospike new key, it wants interface, empty interface. So you can stick a numeric key, you can stick a string key, stick a struct key if you want, although that might be hard to recreate later. Whatever, it all works. Error on, for some reason it's possible to get an error when you're creating a key. I don't know why, but handle that. And then client, which is our client that we created before, put object. First argument is the policy. The policy is a bunch of optional things like you can specify like a timeout for how many times it retries if it fails. So I'm using nil for the default policy. give it our key, give it a pointer to our object we're putting into it. And we set the cookie and redirect like we did before. So pretty simple. This is pretty much the exact same as App Engine. So back on our index page, we're looking things up by the UUID because that's what's in our cookie. So get our cookie, create our key with the bar user's ID, client.exists, default policy key, give us a true false, does that exist, and an error. Doesn't exist, then there's an error getting logged in user that ID, can move on with they're not logged in. Otherwise, it does exist, create a user, client.getObject, default policy key, pointer to our place it's going to store it, and then we're pulling up the username from that object. So again, basically the same as App Engine, except this time we have to detect whether it exists or not. Well, in this case, we want to detect whether it exists or not. All right, so login. So login uses the query stuff. So it gets a bit more complicated. Aerospike queries cannot detect the struct type like App Engine queries do. I don't know, it's just because they haven't put it in yet, or just because they're designed for more languages than just Go. Whatever the case may be, it's not going to give you back a list of users. It's going to give you back a list of results. And then you have to create your users based off of these results. So you create a new statement. A statement is basically a statement in your query. So first argument is the namespace. Second argument is the set, and then it's got our variable arguments for the bin names. So bin is what Aerospike calls our individual fields. So we are interested in the username field because we're looking things up by username. We're interested in the password field because we're going to need that password in order to check if we're actually logging in. And we need the ID field because we're going to need that for a cookie. So in this case, we need every field in our struct. But if you needed less things, this may actually get faster because it doesn't have to look up these extra bins from your large struct, which can be nice. So you got your statement, which is looking up for these in bar users. We add a filter to it. We just call Aerospike new equals filter. And we're going to say that our username bin is going to has to equal our name, which we got from our form. Then we can call client.query, default policy, give it our statement. It'll give us back our RS, which is, that's not what I wanted. I wanted a query, which is a record set. So Aerospike record set. So check our error, defer the record set close. It's actually moving on. It actually sends the query and then moves on before the query results are done, so you can run faster. So we do a for loop, result on range record set.results. So results will give us back a result. And it's actually a channel of results. So every time through this loop, it'll get a new result. So basically, as Aerospike in the background is finding all your items, it's sending them to you as soon as it finds it, and then you can process that particular thing it's found at the same time as it's looking for the next one, which is pretty cool.
Wow.
So the result is a result is a simple struct. It's got a record and an error. So first off, check the error. If there's an error, print so, and then we'll go back to the top of the for loop to look for something else. Otherwise, if there's no error, then we've actually got a record. So the result.record, a record has a bunch of stuff, including the key, node, bins, generation, expiration, a bunch of stuff. We're interested in the bins. The bins is a bin map of basically what we looked up. So map from string to interface empty. So we told it we were interested in username, password, ID. So we've got this bins, which is our map from string to interface, empty interface. We can give it one of these things that we've told it that we were interested in. And then we're going to just convert it. We're going to assert that this interface is this type string. And that creates our user, based off of that.
Are we assuming usernames are unique in our
So
our app?
our code does not check that. We are assuming that it is unique in this particular bit of code because we're breaking as soon as we find something that matches. So don't create two users with the same username. Our code will not tell you that.
Do we
that's not
check
a valid
password
username.
here? Do you check password here?
So down below.
Okay.
So if u is nil, then there was no such user. Then we check our password, and then set cookie and redirect.
So if we wanted to have people have the same username, we could just check password right before the break or something, and if we have a match, cool, we've got a match. Otherwise, each username that comes up that matches the
Yep.
request, the filter, check the password, no, throw it away, no, throw it away, yes,
Yep.
okay, you're in.
Yep.
That'd be cool.
Be interesting, but I don't think that would be the most secure, allowing more than one username or user on the same username.
Yeah.
So whatever the case may be. So yeah, queries in Aerospike is much more complicated. Probably presumably because the Aerospike API comes in like 16 different programming languages, whereas the App Engine only has to bother with 4. So they can have an additional few extra features. Plus, App Engine stuff is made by Google, who made Go, so they can use a few more advanced things in Go for recreating the objects for you. You can stick nearly anything in Aerospike. It's able to determine a large variety of things, and what it can't determine, it'll just convert to a slice of bytes, and it can store that just fine. If you want to manually convert stuff yourself, you can do so. I used put object down here when creating stuff, but I believe there's also just a plain client.put, which takes in the policy, the key, a bin name, and then whatever you want for that bin. So you can use that so same as how we got back from our results, each bin individually in a map, you can use just plain put to put bins one at a time. So if you don't have a struct or something, you can do that. So if you want to manually create a method for a function or something that just manually puts stuff into bins, and then you can create another method which pulls stuff out of a results, you can do that too. But all in all, this is the basics of how you would use Aerospike. So I've got in my big thing of helpful stuff, at the Godoc, a link to the Godoc page. It's got everything. It's a massive Godoc page, actually. If you want more information on connecting, you can find here. We just use the new client, which you give it one IP address, and it'll look up everything else. If you've got all the IP addresses already, there's a command that you can do, so you just give the list of IP addresses, and then it doesn't have to bother looking it up at startup. May or may not be useful. Information on writing a record, which includes that just placing bins one at a time in, is here. Reading a record, including getting bins one at a time, is here. More information on queries can be found here, including things like range queries, where you can say an integer thing. You can do an integer query and you say it must be above this but below this. So a bunch of stuff on queries there. And then I've got this note here about adding that secondary index for things that you're querying on. And that is the end of my Aerospike presentation.
Very cool. Anybody have questions? What's that policy bit that was nil and everything?
So the policy is a little bit of code that tells basically options. So for this put objects, needs a write policy, which tells you here record exists action. It defaults to record exists action is .update, but you could also put on error if it already exists, or generation policy, which I'm not actually sure what that is, but.
So just how to deal with different sort of database transaction events, what do you want me to do? It already exists. You want me to overwrite it, or you want me to throw an error? That kind of stuff. Yeah, so it's basically all options, and if you do nil, it gives you the defaults. So everything also has base policy, which includes priority and the timeout, max retries, how long to wait between retries, stuff like that. So just about everything that you do with Aerospike will take a policy. You can do nil, and it will give reasonable defaults, though.
But if you need a specific action, like don't overwrite, you can manually fill that in.
It's very impressive, Daniel. Thank you very much. That's an awesome example.